Okay. Sand is falling off of a conveyor onto a conical pile. And I'm sure you can just imagine, of course, like a conveyor belt, and you have sand falling onto the ground. So, of course, it just continued to builds up on the top, and of course that cone just eventually gets higher and higher. But it says that it piles up at a rate of 10 cubic feet per minute. The diameter of the base of the cone is approximately 3 times the altitude. At what rate is the height of the pile changing when the pile is 15 feet? All right, so again, let's talk about what's given and what we've got to find. Okay, so here you have cubic feet per minute. So again, this is always going to be a rate anytime you have something per something. Of course, since it's cubic feet and you're talking about this pile that's being formed as this sand continues to build on top, you're talking about its volume, because remember, volume is always in cubic units. So I'm going to refer to this as dV/dt. Okay, so that's going to give me, or it's given to me as 10 cubic feet per minute. Now, the other piece of information that I'm given that we're going to end up using is that the fact it wants to know what is the rate in which this height is changing at the point in time that the pile reaches 15 feet deep. So that would be the height at that particular time. All right, what you're trying to find, as it says, is the rate of change of the height. You know, how fast is that growing? Because obviously the pile is going to continue to get deeper and deeper as the sand comes off of the conveyor. So since we're wanting to know the height of that, I'm going to refer to it as dH/dt. Okay, now the formula that you're going to use here, since you're talking about the volume of a cone, that will be V is equal to 1/3 pi r squared h. Okay, now let's talk about this just a minute. When you go to do the differentiation, of course the 1/3 pi is just a constant multiple, but you have the r squared times the h, which means you're going to have to use product rule. Now, I'm not going to write this down, or actually I'm just going to show it to you here on another piece of paper. If you were to actually go through the product rule, like I said, this is just a constant multiple, so like, you know, first function derivative of second function derivative of first. So I'm going to show you this, but I don't want you to write it down because we're actually going to end up having to change it. So if I were to go through from here to here, like I said, using product rule, this is what I would have. Now, the issue that you have with this problem is when you get ready to start substituting in the given information, you know dV/dt. Now, you are not given the radius. Remember, you were given the 10 and you were given the 15. So you have the 10 to plug in here. You don't have anything given to you for radius. You were not given the rate of change of the radius. You do have, of course, this is what you're trying to find is dH/dt. So, of course, you're not supposed to know this. But you do have to know dr/dt and you have to know r, and that's not given. So what we're going to have to do is actually rewrite our formula so it doesn't have r in it. Like there's no way for me to find the value of r. I'm going to have to rewrite my formula. Now, that's where the sentence here where it says the diameter of the base of the cone is approximately 3 times the altitude. Of course, you know, altitude is height. Now, I don't have the height thrown in here, but you know that would be the distance from here to the center of the bottom. So that's going to be height. So you're told that the diameter of the base, of course, diameter is from one side of the circle to the other going through the center. that it is 3 times the altitude. So I've labeled the altitude as h for height. So that means the diameter from here to here has to be 3h. So see, you're able to rewrite your diameter in terms of the h. Of course, if you can get diameter, you can also get radius. All right, so I know that my diameter is 3h, so that means that my radius would be 3h divided by 2, because my radius would be half of it. So I can substitute for radius 3h squared. So I'm going to come back to my formula over here. And in place of r, we have 3h divided by 2. Of course, that will have to be squared, and then times h. All right, so what we've got to do is do the multiplication here. Okay, so you're going to have to do 1/3 times 9/4. Of course, if you square the 3 over the 2, you're going to get 9/4, and you're going to multiply that times 1/3. I'm going to go ahead, that will simplify, and it'll simplify to be 3/4. Of course, you've got your pi. Now that takes care of the numbers that you have in here, but you also have this h that's to be squared times this h, so that's going to give us h cubed. So I now have a equation that only has h in it, and I'm good with that because I have a value to substitute in for h, that was the 15, and of course I'm trying to find dh dt. All right, so now you're actually ready at this point to do the implicit differentiation. Okay, so we would have dv dt equals, now the 3/4 pi, remember, it's just a constant multiple. And now applying the chain rule on the h cubed, not chain rule, I'm sorry, product rule, so that would give me 3h squared dh dt. Okay, so let's substitute in our 10. We have 3/4 pi. Of course, that's times 3 times h, and that would be squared, and then dh dt. Okay, so let's do the 3/4 times the 3 times the 15 squared. So 3/4 times 3 times 15 squared. Okay. So that gives me 506.25. Of course, you still have your pi, dh dt. Okay, so now let's go from here and come back up here. All right, so if I need to get the dh dt by itself, of course all of this is being multiplied, I just need to divide both sides. So dh dt would be equal to 10 divided by 506.25 pi, and we're just going to get a decimal approximation for that. Now when you put it in your calculator, you do need to put your denominator in parentheses. So 10 divided by 25 pi. Okay, so I get approximately, I'm going to keep 3 decimal places here because the tenths and the hundredths are both zeros, so 0.006. Now, on your units, you're talking about the height of it. Now, since the volume was in feet, cubic feet per minute, then that means the rate of change of the height would just be feet per minute. Okay, so that one showed you having to manipulate your formula a little bit. So if you run across one as you're doing your homework, and you've done the differentiation and you don't have all the values that you need to plug in, sometimes you can find it, and you'll see that with some other problems. Sometimes you can find the information that you need, but like in this case, all I knew is that the diameter was 3 times the height. Like, I didn't have any specific numbers given to me that would help me be able to find that radius, so that required, that I actually needed to rewrite my formula.